Thank you very much for the introduction, and thanks to everyone for joining this webinar this afternoon. I'm going to try and explain the basic principles and details of heat pumps for producing hot water for your domestic property. But yeah, happy to answer questions at the end and go into any other specific details that people want to contemplate or discuss. We've been operating from a premises in Newstead since 2016. It is a former petrol station, so we have transitioned the property from pumping from pumping petrol to pumping electrons, and we even have our own EV charging station attached to an old petrol pump at the front of the premises. And we cover most of central Victoria, from Ballarat to Bendigo, and from Woodend to Maryborough and beyond. So we built up a very strong client base in this part of the world, and yeah, helping people do that transition from fossil fuels to efficient electric appliances, whether it's in the house or in their garage and what they drive. Today, I'm really going to talk about heat pumps in a few different sort of broad themes: the energy usage of the property, the efficiency that heat pumps can provide, some of the specifications of what to look for in a heat pump for your hot water production, some of the details about various rebates that are available to help support that transition, and the general principle of electrification and how heat do that whole process. So generally speaking, in most people's properties, the four major household energy demands fit into these four categories. And obviously on days like today, in the middle of Victoria, in the middle of July, heating is a pretty significant energy demand for a lot of people. Increasingly, cooling in summertime is becoming more significant as we get increased heat in summertime. And then a lot of people don't really think about the energy that's involved in heating their hot water, because when they turn the tap on, the hot water comes out and reliably. And so, yes, but hot water is actually a major energy user within residential properties generally. And even if you've transitioned your property from gas or wood heating to all electric, you've still got this question of what happens every time you start your vehicle and drive down to the school or the supermarket or the railway station. So yeah, transitioning from fossil fuels in a car is pretty significant impact on energy as well. Just in terms of efficiency, hot water, if you're using gas for heating your hot water, whether it's a storage system or an instant gas system, the general efficiency of those type units is around about 90%. So some of the gas that's being burnt is being lost to the atmosphere, and about 90% of the energy from the gas will be used to actually heat your hot water. If you've got an old electric hot water system, the efficiency is a little bit better, 95%. Or thereabouts, depending on the age of the unit. And yes, obviously, as units age and old electric elements get degraded, the efficiency can drop quite dramatically. And then when you switch to a heat pump, you're actually, by the miracle of what heat pumps can achieve, you're actually increasing the efficiency by a factor of 4 or 5, possibly even up to 6 times the efficiency. So there is a substantial efficiency gain to be had by converting to a heat pump. And everyone in their house currently, I would say 99% of people already have a heat pump in their property. It's called a refrigerator. And a heat pump, as the name suggests, it is just a device to move hot air from one place to another. So in the case of your refrigerator, the heat pump is sitting in the back of the fridge, and it's moving warm air out of the fridge and pushing it out the back of the refrigerator, and then pumping cold water. So a fridge is a heat pump, and obviously it has a much lower capacity because it only has to do a small volume of heating air or cooling air. So it's not a huge heat pump. Obviously, when you go to something like a reverse cycle air conditioner, which is also a heat pump, the capacity is much greater because you're trying to heat a large volume of air. With hot water, the same technology is applied. The thing about hot water is that you've got a fixed wanting to heat, and you only reheat the water as it's being used. You don't really have to continually heat the hot water 24/7. It's really just as hot water is drawn out of the system that you have to heat the water, the cold water coming back in. And these days, heat pump technology has now been applied to clothes dryers as well. So if you go into an appliance store, you'll find a whole range of new efficient heat pumps for clothes dryers. So create heat themselves. They use a refrigerant cycle to basically pump heat from a cold place to a hot place. And the real trick to it is that the refrigerant is stored as a liquid at a very cold temperature, like minus something, minus 15, minus 20 degrees. And even ambient air at 5 or 6 degrees Celsius, or in the case when we look at the specifications of the system, even below zero, that air that's coming into the system can actually boil that liquid refrigerant, turn it into a gas, which then gets passed through a compressor, similar to the little compressor in the back of your refrigerator. And that compresses that gas and pressurizes it and turns it into a hot gas, then passes it through a heat exchanger to basically transfer that heat into your water supply. Cold water coming in, hot water going out. And because it's a closed loop system, as that refrigerant transfers that heat out into the water, it cools to a liquid again and goes round and round and round the cycle for the amount of energy and time that's required to heat the volume of water necessary. So it's a very clever chemical process. And yeah, this is where the efficiency is generated, because the amount of energy required to run the little compressor is quite low, and the amount of energy that's then transferred using this chemical process of the refrigerant, liquid to a gas and back again, is where the energy efficiency is achieved. It's pretty simple, but yeah, that's the basic principle of how a heat pump actually does its work. Yeah, and as I say, 1 part of electrical energy can often produce 4 parts of hot water heating, and maybe even in really good climate conditions, warm conditions, when the air temperature when the water in the system is at a modest temperature and the air, then it can even get up to 5 or 6 degree times the amount of electrical energy coming in. And yeah, the good thing about heat pumps is that they qualify for all sorts of energy efficiency certificates, just like solar panels on your roof, or nowadays battery storage for your house with the new federal government battery rebate. And that's just an example of that's a split system heat pump, which we'll talk about in a few moments. So the specifications that one needs to contemplate or consider when you are thinking about switching to a heat pump system. Obviously, the size of the unit. There are different sizes for different demands in terms of number of people living in the property. There's the COP, which we'll go to in a moment, the coefficient of performance, which is a measure of the efficiency of the system, the type of refrigerant that's being used, what range of temperatures that they are suitable for, particularly units like Central Victoria, whether the units have a backup element, to what degree the system is programmable, and we'll go into the detail of that shortly, how much noise they produce, what the warranty is on each system. And there's now a new requirement in Victoria that if the system qualifies as having a certain level of Australian content, it can attract a higher rebate. So we'll look at each one of these in turn. This is the general guide to how big a system you should be looking at. And heat pumps are all storage systems. They are not instant electric systems. There are such things as instant electric hot water devices, but they require a very, very high current and a very inefficient in the broader sense. So we don't recommend that at all. Heat pumps are by far the most efficient way of doing your hot water. So yes, if you've got a 1 or 2 person household, less than around 200 litres is more than sufficient quantity of hot water. If you go to a 3 person household, somewhere between 225 and 3 adequate. And any property with 4 or more people, generally speaking, you're looking at 300 litres or more in terms of storage. All of these factors, can be discussed with individual clients as to what their particular requirements are. And then in terms of configuration, you've got, in principle, 2 different types of systems that can be installed. On the right-hand side, you'll see there's an all-in-one unit where you at the base, and then on the top third of the unit, you've got a compressor sitting up there with a control panel, and that does that's the actual heat pump unit. So it's sitting in on top of the tank, so all in one. Whereas the system on the left is what we call a split system, just like you would have for a split system reverse cycle air conditioning unit. You've got a heat pump. In this case, it's been wall mounted. A heat pump round on the left-hand side of that picture, sitting on the wall, and round on the right of the picture, tank, 2 separate units that are obviously plumbed together. And the benefit of a split system is that it's generally more efficient energy-wise. Also, it allows much better, more flexibility in terms of positioning, location, configuration, obviously, and if space is a significant question mark. And yes, as you can see in that previous picture, there are different size tanks, and there are also 2 main different types of tank. The high-end products generally have a stainless steel tank, whereas mid-range units are normally what's called a vitreous enamel tank. And as such, they do have an anode sitting inside the tank, which is a sacrificial item that collects impurities in the water, depending on your water supply, and attracts them to the anode in a chemical process. And that anode may, depending on the use of the system, could replace 6-7 years, something of that nature. So yeah, 2 different types of tanks. And yes, generally speaking, they come in sizes from 200 litres. A couple of them are smaller than that, but generally 200 litres up to 400 litre size tanks. This is where we get into some of the technical components of the system. So the coefficient of performance, the COP, which is basically a ratio of heat output to electrical kilowatt of energy that goes into driving the system, has a ratio of how much heat that can produce. And this is based on 2 key components. One is the ambient air temperature that the system is operating with, and equally the stored water temperature inside the tank. So the warmer the water that's in the tank, obviously the less energy is required to run the system, so the greater the efficiency. And all of the rebates that are attracted from the federal government, which are called Small Technology Certificates, STCs, they apply automatically to anyone that's installing a new heat pump. There's no means testing or anything like that. It just gets accounted for in the cost of the system. And the value of the rebates, the amount of the rebates, is all based coefficient of performance. So the higher the COP, the more rebates the system will attract. And one of the top end systems in the Australian market is called a reclaim unit, which has a stated COP of 6.09 at a couple of, as I say, in summertime, when the air temperature outside is 32 degrees and the water temperature inside the tank is 21 degrees. That's how they measure the COP. And obviously in wintertime, is much lower and the water temperature is much lower, that COP will be slightly less. So yes, when you looking at the specifications and the performance of a heat pump for hot water, the COP is one of the key criteria as to how efficient the unit can operate. So it's a key reference point. Then in terms of refrigerant, there are all sorts of different refrigerants that have traditionally been used in heat pumps. Nowadays, because of climate change, warming issues, refrigerants are now being considered in the context of what their potential is to add to global warming. And so from 1st of July 2024, last year, in Victoria, any hot water heat pumps that are being installed must have a global warming potential of less than 700. And the most efficient types of heat pumps generally use a refrigerant called CO2, or carbon dioxide, obviously, and that has a global warming 1. So that's the sort of benchmark, really. And yeah, as you can see, if the CO2 potential is 1, then you can actually install systems that are up to 700. So that's a fairly sizable range of the global warming potential. Another common refrigerant being used these days is a gas called R290, and that has a global warming potential of 3. Some of the older heat pumps that may have been installed before July 2024 used to use a refrigerant called R410A. And as you can see, some of these old refrigerants have an incredibly high global warming potential. In the case of R410A, more than 2,000. So that ratio is quite significant. And as the technology, I guess the key message here is that heat pump technology has gradually been improving, or quite improving. All of the COPs, coefficient of performances, are improving. The type of refrigerant is constantly being improved. So yeah, we're getting more efficient units that are less damaging to the environment, potentially. The operating temperature, as I said, in central Victorian, wintry conditions in particular, it's really important to understand how well your system can perform in cold climate situations. So we would recommend having a system that at least is capable of operating as a heat pump down to around -5 degrees Celsius to cope with frosty mornings in central Victoria. And that will be without using the backup element. So some of the cheaper units in the marketplace will operate as a heat pump down to possibly 0, maybe 2 or 3 degrees Celsius. And when the temperature drops below that level, they then have a backup electric element, which is not heating hot water, that has to kick in when the air temperature is too low. As I said, one of the top performing systems in the market is the Reclaim unit, and that is rated as a heat pump, no backup element at all, down to -10 degrees Celsius. So there are systems out there that can cope with cold climate conditions, but you just have to be very clear on the specifications as to what the operating range is and whether the system requires a backup element or not. The defrost cycle. So even though we would normally program a heat pump to run during the daytime, which I'll come to in a moment, the system will, even if it's not actively heating the water, it's in a very cold conditions when the air temperature is below 0. The unit will need to run a defrost cycle at certain periods, particularly early in the morning, like 5 a.m. in the morning when the air temperature is very, very low, because the last thing freeze up. So they will operate a defrost cycle regardless of what other programs have been set to keep the water inside the heat pump unit at above 0 degrees so that it can't freeze up and cause damage to the heat pump. So you will occasionally hear these units running a cycle early in the morning to keep water flowing. When you start using your hot water for bathroom, laundry, kitchen, etc., obviously you're taking hot water out and cold water is then filling the tank from the bottom of the tank, and then you have to consider the recovery rate. As I say, in the recovery rate of how quickly the unit can reheat all the cold water coming in is dependent on the climate conditions and the temperature at the time. In summertime, most of these systems can recover and reheat around about 60 to 70 litres per hour. In winter time, in the daytime, not time, if you're using the hot water, it will be able to recover at about 50 litres per hour. But these numbers will vary depending on the performance of the system, the amount of hot water being used, and the temperature at the time. So that just gives you a rough idea. If you've got a 300-litre tank, you should be able to reheat the whole tank in around about 4 or 5 hours in the middle of winter, generally, if you take out all of the 300 litres of water, which is not very common. As I say, the good quality heat pumps are definitely and recommended to be programmable. The reason for that is that you really want your, traditionally, of course, everyone has had electric hot water systems on what was called a controlled load, where they were running overnight after 11 p.m. at night, typically, on a cheaper electricity tariff. And those tariffs used to be often less than 10 cents a kilowatt hour. You won't find many of them left, unfortunately. So power is now quite a bit more expensive. But the key thing is that with a heat pump, you really want to program the system to do its main heating cycles during the daytime for a number of reasons. One is that the air temperature during the daytime is typically much higher than overnight, obviously. So having the air temperature at a higher level means that the efficiency of the unit improves. Secondly, nowadays, most people, although not all, are on an off-peak tariff up until 3 p.m. in the afternoon. So peak tariffs are typically 3 p.m. to 9 p.m. And so most people are getting off-peak power all morning and for the first half of the afternoon up until 3 p.m. So you are still getting the cheaper rate of electricity to heat your hot water during the daytime. Some people and some retailers are now offering free electricity for 2 or 3 hours in the middle of the day. That could be 11 a.m. to 2. So if you program your hot water service to run during that 3-hour period, you can actually run it at zero cost for your electricity. And obviously, if you do have solar panels on your roof already, as the solar feed-in tariff keeps falling, and I'm sure some people will have comments about that in due course, but yeah, the feed-in tariff that you get for selling your excess solar back into the grid is going down, down, down. So it's much more effective and efficient and cost-effective excess solar to do more of your heating loads during the daytime, which includes a heat pump that can be programmed to run during the daytime. And some people get concerned about, well, if we put this program on to restrict the hours of when the heat pump can be heating water, what happens if I need more hot water? Most of the good quality systems in the market now have a boost function, and it's just one button. So if you suddenly have a requirement for extra hot water, you just basically, and this can be either on the unit itself or on a remote control, and it will start heating regardless of what the air temperature is or the tariff or how much solar is coming off your roof. You can just get the system to start heating instantly without waiting for any of those program functions. Hope that explains the benefits of a programmable system. Some people have asked about the noise of heat pumps, and generally speaking, heat pumps should be noise units. They all have different noise ratings in terms of the particular units. Mostly, as I say, they're being programmed typically for running during daytime periods. So generally speaking, you won't hear the system operating because it's in the normal daytime with background noise and motor vehicles and other activities around the house. So yes, they would be very, generally speaking, hard to stand right next to the unit to hear it operating. When they are running a defrost cycle, they may actually operate during the middle of the night or early in the morning. So you may hear a system kick into gear at 4 or 5 in the morning in really cold conditions. So that can change the amount of noise that you're hearing. Decibels, which is what any appliance like this is rated in, the number of decibels, it's a logarithmic scale. if a unit is rated at 30 decibels and a unit is rated at 60 decibels, it actually means it's like 100 times more noisy. So it's not a linear scale where it just goes up incrementally. It's a logarithmic scale. And generally speaking, a system that has a decibel rating of below 50 decibels is much preferable. That's about the same as a normal refrigerator. But obviously the heat pump unit is going to be located outside the property to get access to the airflow. It'll be outside your wall, it won't be inside the house. But yeah, going to less than 50 decibels is definitely recommended. In terms of rebates, there are a range of rebates available to support the upgrade to an efficient heat pump for hot water. As I mentioned, from the federal government, you get small technology certificates by default. They just come as part of the cost of the system. In Victoria, we also have Victorian certificates known as VEECs. And again, they get applied automatically. They vary depending on what you're actually replacing. So if you're replacing an old gas hot water system, there are fewer VEECs available. If you're replacing an old electric storage system, you get more VEECs. And the number of VEECs will depend, as I say, the number of certificates generally depends on what you're replacing and what system is being installed. Then we have the Solar Victoria program, and this is a means-tested program in Victoria. So that's a system to support the uptake of solar panels and efficient hot water units with heat pumps. In the case of the hot water system, the rebate is $1,000, but it is means-tested, so your household income has to be below $210,000 per annum, and the value of your property has to be below $3 million. So it's pretty generous. And there's a fairly good rebate. Go through and claim that rebate. It's very simple. In addition, if your system qualifies, if the heat pump that's been installed qualifies on the list of units that have a degree of Australian content, and there's half a dozen units that have qualified for this component, then the Solar Victoria rebate increases from $1,000 to $1,400. And yes, inform you as to which unit is eligible for the higher Solar Victoria rebate of $1,400. So yeah, that's the broad rebates. There are, if anyone is listening in Ballarat, the city of Ballarat has another scheme on top of this, which has a local rebate for hot water as well. I can't remember the number off the top of my head. I think it might be $500. But yeah, the city of Ballarat then has another rebate process to add to all of these other rebates. And I should add that all of these are stackable. So you get STCs, you can get the Solar Victoria rebate all together. And even if you claim the hot water rebate from Solar Victoria, that does not disqualify you from having a rebate for adding solar panels to your property either. The costs and savings benefits to be obtained by upgrading your heat pump. So a cheaper system in the marketplace, you'll find there are literally hundreds of different heat pumps in the marketplace. A cheaper one will probably, the install cost may be somewhere around $2. The installation costs, plumbing and electrical. A lot depends on where the heat pump is going to be located, and also what you've got available in terms of your switchboard. We sell two main units here at the Enviroshop in Newstead. One is called an ether unit, designed and developed in Geelong, and that's an all-in-one unit. It's a slightly higher performance system, so it's generally about a $4,000 upgrade. The Reclaim unit that I've mentioned a few times, which is the split system and a very system, is a lot more, as you can see, is a lot more expensive. You're talking about maybe even $7,500, again, depending on the particular site details. So yes, there are a whole range of products in the market at different price points and different capacities, different performance specifications, etc., etc. If you are replacing an old electric hot water system, typically, and this will depend on the age of the system and the size of the system, and how big an electric element it's got and what your electricity tariffs are. But typically, you can be saving somewhere around $800 per annum by switching your old electric hot water service to a heat pump. In the case of gas, the savings on just replacing your gas hot water may only be a few $100s, but on top of that, this is the benefit of the full electrification process, is that if you can replace all your gas appliances, and about not LPG, gain is to avoid the daily supply charge for gas. So that's about $1 a day typically, so almost $400 per annum. So if you the gas hot water unit, you're saving a couple $100 in gas consumption and potentially giving you the capacity to then save the mains gas connection fee of $400 per annum. And that the problem with, as people substitute gas appliances with electric appliances, the number of people on mains gas is going to keep shrinking. So those supply charges are inevitably going to increase. Yep. There are a whole range of, just quickly on other rebates, the Victorian Energy Upgrade Program, which some of you may have used, has a whole range of upgrade programs. There's a program to upgrade heating and cooling systems with reverse cycle air conditioning, hot water we've mentioned. You can get a rebate on a new heat pump clothes dryer, on induction cooktops. There are all these programs to improve gap sealing, LED lighting, water efficient shower heads, and as from next year onwards, there's going to be a new rebate through the Victorian Energy Upgrade Program to cover ceiling and wall insulation, and I think maybe underfloor, but upgrades to properties as well. Yes, so keep an eye out on all those programs, and there's all sorts of companies around the place who will be able to provide services in those range of areas. Just very quickly, the whole process of the benefit of electrification is that currently, if you are using mains electricity and mains gas, you're paying 2 utility bills. So you've got 2 supply charges each and every day of the year. And it is generally, a big saving if you can eliminate one of those, which would be the gas supply. So this whole process of electrification, apart from the energy efficiency gains to be had, is about reducing your energy bills by eliminating one of those items, the gas bill. And equally, if you're using more electrical appliances and you've got access to solar power off your roof and or overnight, then you can be running much more of your house from renewable energy. And as the grid also increasingly, we are adding more and more renewable capacity into the grid. So even if you're drawing electricity from the grid, the amount of that energy that's coming from renewable sources is increasing significantly. And in Newstead, we also have the benefit of the Newstead solar farm, which was opened last year, which producing enough solar energy with battery storage to cover the general electricity needs of the town of Newstead, which is fantastic. And electrification also means you're getting the extra gains of more efficient appliances as heat pump and other technologies improve. It's also a healthier system. You're not having old gas appliances that are leaking and producing off-gassing, etc., etc. And just a final note is that as from the 1st of March 2027, so 18 months away, it's a requirement in Victoria that any old gas hot water systems that have to be upgraded or replaced must go to a heat pump. From March 2027, you will not be able to install a new gas hot water service. Everything will have to go to an efficient heat pump. That's a new rule from the Victorian government. Just very quickly, this is what we actually do at the Enviroshop Newstead. We generally do comprehensive energy properties to understand their energy use and give them recommendations on improved energy efficiency and including things like doing improved insulation, adding ceiling fans, upgrading heating and cooling systems. Obviously, we supply and install heat pumps for producing hot water. We Install systems for producing solar energy off your rooftop in a grid connect scenario. We don't really do off-grid work at all. Yeah, this year we've just been overwhelmed with demand for battery storage with the new federal government rebate coming into effect from the 1st of July. And we've been very active in promoting the increased uptake of electric vehicles. As I say, we have our own charging unit here at the shop, but we also run monthly sessions with EV owners to explain their experience with driving an EV. And our website has details of those events coming up. Bottom message, the future is all electric. We don't need fossil fuels any longer. Fossil fuels are inefficient, too expensive, and too harmful for the environment. So all the technology are able to run our houses and our vehicles with electric energy, and that is the way of the future. And if we can help customers move down that pathway, that's what we're here for. Thank you very much.